Hello everyone, let's take a look at the C++ code for this top-down game and see what details are worth your attention. First, let's look at uPublic. There's nothing wrong here. This is the main module of the game, along with the regular editor plugin, then editor, and then this game's targeting.c, yes, which is also fine. What we need to pay attention to is this Build.cs. You'll notice it not only has the enhanced rapid writing system, but also includes the AIModule, Niagara, and NiagaraSubSystem. It's not called subsystem, it's called system. So if you want to use the corresponding Niagara particles in your C++ code, Niagara particle system, you might need to include these two brothers. And if you're dealing with AI, you might need to include the AI module. Sometimes when you watch tutorial, you find your code is exactly the same as the tutorial, but you still can't compile. That's because you didn't import the correct modules. And over here, there will be a log. It's defined somewhere else. We'll just ignore it, right? And this is the main game module. Never mind, it's just character. And as for this character, it inherits from a character. There's really not much to it. It just has a camera created and a camera boom. You can see, and in its constructor, first we modified the capsule component size. There's no need to rotate the character to face the camera direction. And here because we have enabled this area, it makes it rotate following the direction of movement. Then here we modified some of its rotation speeds and some properties, etc. Then here we created a camera, such as spring arm, a boom. Then we set after camera boom because we want a top-down view, so we fixed it to this top-down camera position. Then we create a camera and attach it to this camera boom. Then here, tick is turned on. So sometimes it's like this. Why can't you tick? It might be right here. You need to turn it on. Okay. Then as for this game mode, there's nothing much to say. It's also the same old method. What it uses here is the player controller. It directly uses the C++ player controller here. You will notice, then here it is. However, it still went through this. To look for this, is there a blueprint implementation like this? You will find that here, if it can find this blueprint implementation, it all uses this. We can take a look. In his project, this implementation should be done. We generally do not recommend writing it this way. That is, writing this kind of code, because this is hard-coded, well, that is to say, its readability and portability are both very poor. Yes. If you change a name or move a position, you will find that in this code, it will no longer work. Okay, let's take a look. Actually, you will notice, why is our first project so complicated? Because you need to know, Unreal Engine started out making design games. So this design project, this code is the most complex. And it's actually not very good at making RTS game, because when it involves a massive number of actors, it becomes particularly troublesome to handle. Then you will find that inside this blueprint, it indeed has a player controller. So its prof is this tool. You see, it mainly does asset configuration, because in these two places, hard coding like this is already too much. If it also hard codes these assets, then what is the point of blueprints? So it retrieves these resource configurations from blueprints. That's roughly what it means. You can see, okay, we can see that this place is also just a simple resource configuration. As for the rest, there's probably nothing much to say. Then we remember we must have used enhanced input. In our input, it must have been changed. That is in project settings. The input here has definitely been changed to truth-based input. Okay, then let's go back to our player controller. So, the player controller first declares that it will use some properties. First, you need to take the Niagara example. Which Niagara example you want to, which input mapping table you use, and what needs to be mapped. This touch, we won't worry about this touch screen. We'll just use mouse clicks. So this is the time, right? Then we can see in the player controller, yes, you have this. Take a look at this flow. It should be doing an initial draw instead. Then this is where it is bound, and this is what it needs to bind to. These methods on this input action. Note this touch, we can completely ignore all of it. Then this actor buffers that position, and this part distinguishes whether it is a touchscreen device. And this is a follow time. Okay, let's see how it is written inside. First, in the constructor, he sets this player controller. We often set it to mouse. Hurry up and get this mouse done first. Then this default mouse cursor. There is an enum here. It indicates which type of display it is. We'll just set it to the default one for you. Then we set the second parameter. We give it a 0. Then follow time. We give you a 0. Then during BeginPlay. We call the parent classes BeginPlay. As for this time value, it might be modified in the blueprint class. Yeah, this is configurable. It is configured in the blueprint class. We don't need to worry about it. Then this binding here, it will automatically bind. First, bind our input mapping. Then it starts binding here directly. That is binding the corresponding input actions. That is how to bind to these actions. Okay, you can see here, we should be using this, and we should have bound these 4. Let's check these 4 methods. So the first of these 4 methods is when it is activated. We first extract all movement when everyone is in an activated state. Then here, it will perform an accumulation of flow time. It should be an accumulation of flow time. Ignore this accumulation for now. Here it calculates the current position of your pointer. You can see this function. It is actually inside the PlayerController. It is this function. It will pass in sum. This should be this function. Pass in this channel. Then complexity detection. Finally output the result. Then if the detection is successful, we just need to update the position. Then after we get this pump, because we are continuously emitting a stream of fire, we add to it the input value of this movement component. And as for this direction, it's essentially doing addition and subtraction with vectors. Then we just normalize it, okay? So overall, during the continuous recurrence, it's this stage. When it cancels, you can see when it cancels or completes, it is all here. It will make a time judgment here. This time, if you accumulate this time, because this time will keep adding, it depends on how long you pressed. If you pressed for a very short time, we consider it a single click. We do it through BP library. This BP library is very important. This is very important inside this AI module. We often use these methods inside it. Then there is a method in this BP library. It can move the controller's pump. Let it move over. And here is where we generate the special effects. This method is also very important. Very important. This is inside this Niagara, inside this BP library. Here, if you want to generate some particle effects, such as a hexagram, or flame, or ice spikes, then you can use the methods in this BP library frequently, okay? Then, after finishing this, reset this time to 0. This means the current activity is over. We don't need to look at this wrapper, so just ignore it. Basically, its code is quite concise. It's probably only about 100 or 200 lines. Basically, I finished the entire logic for it. Then remember to include the header file. I've taught you how to include header files before. It shouldn't be a problem. Okay, that's it for this case. I don't think there's much to say about these 1 or 2 files. You guys try to replicate it on your own. And note that it's possible that the blueprint did some parameter configuration because, for example, here, it clearly doesn't have an initial value set. Since you marked it red, it will initialize it to 0 for you, right? So it must be injecting the configuration in the blueprint. Everyone should try it out on their own. We can take a look. Here, we need to compare this part. You see? Its time is 0.3. Ours was 0.5, right? And these assets have been assigned accordingly. This way, everyone can distinguish. Why did he modify this? But you don't need to study every single option, why it was modified this way. How to modify it. You still need to base it on your own needs, whatever need you have. Check if the engine has relevant parameter setting. Then think about the engine again. Why is it designed this way? Are there other ways provided to you instead of reinventing the wheel yourself from the start? This is a simple learning method. Just a quick mention. Okay. You see here, roughly, these things have been changed. These are some things like the camera's FOV, you also see, and these things about navigation. These are all small blueprint points, nothing much to say. Good for this chapter. So I briefly introduced these 3 points to everyone. Okay, we'll stop here. Thank you everyone.